Alright guys, up until this point we have been talking about the properties of log functions. Okay, so now we're going to talk about evaluating log functions by hand. So in order to do this video, you're going to have prior knowledge of the properties of log functions. And again, I did make videos on those, so make sure you watch. Okay, so let's go ahead and go into evaluating log functions here. So we'll do our first problem, and we'll have log minus x, and then we'll have minus log 4, and this will all be equal to 1. Okay, so go back to your properties of log functions. Notice here that we are subtracting. Also notice that we have the same base. Remember, if it's not given, you assume that we have a base of 10. So both of these logs here have a base of 10. Okay, we're subtracting, all right, and with our knowledge of properties of log functions, we know that we're going to be dividing here. Okay, when we subtract, we divide. So we can rewrite this now as log, and so we'll put base 10 here, okay, and we'll have negative x all over 4. And again, this will be equal to 1. Okay, so that is what we have so far. Now I want you to think about how we can go about solving this now. How can we go about solving this? So think again, go back to your properties of log functions, and think which property would be useful here. Now, how can we isolate this? How can we get rid of this log here? All right, how can we get rid of that log? And if you remember, the properties, the inverse property, all right, can be used here in order to get rid of that log. Now remember, since this is an equation, what we do to one side, we also have to do to the other side. So, if I take this whole thing right here, okay, and I put it as a base of 10, so if I do 10 raised all to this, let's see what that looks like. So if I do 10 raised to log base 10, and then negative x over 4, okay, well what I do to one side, I also have to do to the other side, so this will be 10 to the first power, okay. Notice this is the inverse property, right, we talked about with log, so this will simply cancel out, okay. And what I'm left with now, when I do this, is going to be negative x all over 4, okay, and then we do 10 to the first power, right, which we all know is going to be 10, right, so we write 10 here. Alright, now we can simply solve this. We just multiply both sides by 4. So we're going to get here negative x equals 40. And now just simply divide by negative 1 on both sides. So our answer here is going to be negative 40. Alright, and we are done. Alright, let's try another problem here. So let's take a look. See what we have. Let's do log x plus 3, and then we'll have minus log x equal to 1. Okay, again, using your properties of log functions, we're dealing with the same base here. Okay, so we know that we have subtraction, we're actually dividing. So we can rewrite as log base 10, and then we'll have x plus 3 all over x. Okay, and this will be equal to 1. Again, same thing. How can we isolate? All right, our x is here. So what could we do? And again, if we use the inverse property here, all right, we're going to be able to do that. So again, I'm just going to simply put a base of 10 here. So I'll have 10 log base 10, right? X 3 all over x. And again, what I do to one side, I also have to do to the other side, so this will be 10 to the first power. Okay? Well, again, we know that the inverse property of logs, right, this will cancel. Now we're left with x plus 3 all over x equals, and this will become 10. Right? Multiply x on both sides, so we'll have x plus 3 equal to 10x. Subtract x on both sides, we now have 3 equal to 9x. And now just simply divide by 9 to solve for x. So when we divide by 9 here, we get 3 over 9, which is going to reduce to 1/3. Okay, so x here equals 1/3. All right, and we are done. All right, let's try another problem here. All right, so a little more tricky. So let's do x minus log x plus 3, and this will all be equal to 2. Okay. Again, we're dealing with the same base here. Again, we have a base of 10, base of 10. We're subtracting, so we know that we need to divide. So let's go ahead and do that. So we have log base 10, then we have x over x plus 3. This is all equal to 2. Okay. Next step, use your inverse property of log. So if I use a base of 10 of here and a base of 10 of here, right, they'll cancel out. So 10 log 10, and you have x over x plus 3. This will be 10 to the second power. Well, again, inverse property cancels. So now we're left with x over x plus 3 equal to 100. All right, almost done. This whole part right here, we're going to multiply both sides by. So I'm multiplying x plus 3 here, cancels, x plus 3 here. Okay, so moving on, we're going to have x equals 100 times x, which is 100x, and 100 times 3, which is 300. Okay, let's go ahead now and let's subtract 100 on both sides. So when we do that, we'll have negative 99x equal to 300. Okay, and now when we divide the two, so if we do 300 divided by negative 99, okay, we get negative 3 point, let's put negative 3 here. Okay, so we're going to get x will equal negative 3.03, or we can say x equals about negative 3. Okay? Alright, so x is about negative 3 here. Now, what I want you to do, okay, before you go ahead and circle this as your final answer, okay, I want you to look what we originally had written here. Now, there's going to be a problem here, and this is when you need to check for extraneous solutions. All right, so remember, extraneous solution is we went ahead, we solved, we got a solution, but it may not necessarily work here. Okay, I'm going to take you through that right now. So think about this. If x is about negative 3, if we plug that in here, okay, if we plug in that negative 3 here, what will happen? Well, we'll have negative 3 plus 3, which is going to be 0. Okay, so why don't I go ahead and erase some of this work so I can show you why this is going to be an issue here. So again, if I were to plug this negative 3 into here, it would be log negative 3 plus 3, and this will be log of 0. Okay, so bear with me here. If I'm looking at what I have here, when we write our log equation, we could write this as y equals log of 0. And when we put it into its exponential form, well, how will this look? Well, remember, this is a base of 10, so we'll have 0 equal to 10 to the y power. Now here lies the issue. What can I put in for y here in order to get this to equal to 0? And the answer here is going to be nothing. I can't put anything in here for y that will give me 0. Remember, 10 to the 0 power, right, is not going to be 0. It's going to be 1 here. Okay? So I can't plug in anything here that's going to give me 0. Meaning, okay, this is going to be an extraneous solution. And if this is an extraneous solution, the answer to this problem is no solution. No solution. Another easier way to remember this, if you have log of 0, okay, that is impossible. Okay, that would be no solution. Alright, so for this problem here, it is no solution. Alright, and that is evaluating log functions.